Righty, good day, Matrix. So, okay, the stuff here is on your test on next Friday. It will also have helped a lot if you've done that revision that I sent you a while back on the grade 11 type of questions. But anyway, what we're going to be doing is Pythag type questions with an extension in terms of that we're going to use within those Pythag type questions. We're going to use compound angle and double angle formula as well. So please make sure you have your information sheet with you. And we're going to be working from Mindborn Maths, exercise 4.6, page 146, and we're doing A, C, E, G, and I. So first of all, the way you recognize these types of questions is it says without a calculator normally, and with the aid of a diagram. So those are your two instructions, without the calculator, with the aid of a diagram. And that's generally your hint that you're going to be using this. It's also not going to be special angles or anything like that. So, the question, the first question, question A, says the following. Given sine theta is equal to negative 5 over 13, and theta is an angle of magnitude between 90 and 270 degrees, calculate cos theta, sine 2 theta, and cos 2 theta. So, you're going to start off exactly like you did in grade 11 and in grade 10 actually. Okay. And this is, remember, your method that you basically use. You isolate the trig function. Well, we've done that. Right, the next thing you're going to do is use both bits of information given. I make a tick for one and a cross for the other to determine the quadrant that the angle lies in. So, go and give that a try and find out, figure out which quadrant you're in. So we've got sine is negative. Where is sine negative? In that quadrant and that quadrant. Remember that the cast diagram tells you where the trig functions are positive. So I'm going to make mark with a tick. Okay, that's where sine is negative. But then we're also told that the angle lies between 90 and 270 degrees. So between 90 and 270, going anti-clockwise, means I must either be there or there. Okay, and where both the tick and the cross occur, that must be the quadrant that we're working in. So we can start drawing the diagram. So I'll put a point in that quadrant, join it to the center, draw in my angle theta. Get your diagram right. So there is theta. It's an angle between 180 and 270 if it's less than 360. Right. Now, you write down what you're given. So you're told that sine theta is equal to negative 5 over 13. You're going to use your definition, shade your rear. So sine is equal to the y-coordinate over the radius. So that for this angle theta, we know that if the radius is equal to 13, then the y-coordinate must be equal to negative 5. Okay. If the radius is 13, then the y-coordinate is negative 5. So we have to go find the x-coordinate. Now why the hell do we even need this diagram? Well, diagram tells us that the x-coordinate is going to be negative. So I would straight away remind yourself why you're doing this diagram and put a negative in there. Because without the diagram, you wouldn't know whether the x-coordinate is positive or negative. Right. So now, I'm going to use the fact that on the Cartesian plane, the x-coordinate squared plus the y-coordinate squared is equal to the radius squared. That's the equation of your circle. To find, or Pythagoras, to find your missing variable. Okay. So that says use x squared plus y squared is equal to r squared to find the missing variable. Determine whether it's positive or negative. Okay. Determine if it's positive or negative using your diagram. That's the point of the diagram. So, we start off and we can say x squared plus y squared is equal to r squared. Right, go find x, and we're going to have, therefore, x squared is equal to r squared minus y squared, which in this case will be 13 squared minus 5 squared. Okay. Which is equal to, so therefore y is going to be equal to the square root of 144. 169 minus 25 is 144. So y is plus or minus. So because y squared is 144, so y is equal to plus minus the square root of 144. So y coordinate could either be plus 12 or minus 12. But this is where we need the diagram. The diagram tells us that here's my point. So in fact your y coordinate is equal to negative 12. Okay. So y coordinate is negative 12. So let's just clear up the water a bit. So obviously a deliberate mistake there, checking if you're paying attention. We were solving for y, so I mean for I've done it again. So we're solving for x, so x is equal to plus minus root 144, so x is plus minus 12, so the x coordinate is negative 12. So we could go pull that in over there. Okay, y is so what I know is for angle theta, if the x coordinate was negative 12, then the y coordinate would be negative 5, and the radius would be equal to 13. Remember, x in fact could be negative 24, then y would be negative 10, and r would be 26. It's just those ratios, right? Okay, so now, just a reminder, you wouldn't have to go through all these steps if you start recognizing your Pythagorean triples. So you could have just, if x is 5, if 1 is 5, 1 is 12, then the other one is 13. That's your one Pythagorean triple. And we've got the most common one, 3, 4, and 5. Okay, so that's just a couple of basic ones. So you could just use it. So in other words, in this question, you could have just gone, okay, once you've got the y, you wouldn't have to show all those steps. You could just have said that x is equal to negative 12 Pythag, and you get full marks instead of showing all that x squared plus y squared is equal to r squared stuff. Okay, so 5, 12, and 13, 3, 4, and 5 are two that you can just use. So you don't have to show all the work. Okay, so we found the missing, so we know that for this angle theta, if x is negative 12, y is negative 5, r is 13. Then it says, once we've done that, then we can start engaging with the questions that are asked. So last step, answer the question, and from now, this is the one difference compared to last year, you may need a double angle or compound angle formula, okay, to answer these questions. So the first question is pretty straightforward. Okay, cos is the ratio of the x coordinate over the radius. We're working with angle theta, which is what we've got. We've got the ratio for theta, and so the x coordinate is going to be equal to negative 12, and the radius is 13. So cos theta will be equal to negative 12 over 13. Right, for sine 2 theta, please, what you can't do is you can't go and say, if these are my ratios for theta, then for 2 theta they'd be doubled. All you would be doing, you'd be extending that. You said x was negative 24, okay, y is negative 10, you'd still be working with angle theta, okay, you've just changed your ratios. So, what can we do? Well, we've got formula which I can only work with angle theta. How do I get from angle theta, from an angle of 2 theta to an angle of theta? Well, the only formula that links those up is that we know that sine 2 theta is equal to 2 sine theta cos theta. And my diagram relates to angle theta, so I can go from there. And if I go do that, I get 2 sine of theta is what, please? Sine of theta is equal to negative 5 over 13. And cos of theta is equal to x over r, which is negative 12 over 13, which is going to give you, what, 10, 2 sine theta, 120 over 169. Hope you can see that. So the final answer you should get is 120 over 169. Right, and the last one, you've got to work out the value of cos 2 theta. Tatiana, if you could take us through that. Okay, and you look at your information sheet. We can't work with 2 theta, we've got to work with angle theta. Okay, so cos 2 theta would be equal to, well, we could change it to one of three things. Tatiana picked cos squared theta minus sine squared theta, okay, which means cos of theta all squared, and cos of theta is x over r, which is negative 12 over 13 squared, minus sine theta is y over r, which is negative 5 over 13 squared, which is going to give you 144 minus 25 over 169, which is 144 minus 20 is 124 minus 5, I'm sure it's 119 over 169. So your final answer is 119 over 169, which is exactly what Tatiana got. Congratulations, fellow Bedford viewer. Alright, we're going to do 4.6c, no calculator. So again, we know it's going to be a Pythagoras question because it says no calculator with the aid of a diagram that you're in that kind of space. And now we're given two bits of information. You're told that two angles you're working with. Tan alpha is 12 over 5 and alpha lies between 90 and 270. And cos beta is negative 8 over 17 and beta lies between 0 and 180. And the question says go evaluate sine of angle alpha plus beta. So you can't add them together or anything weird like that. You have to use your compound angle formula. And if you go to your formula sheet, you'll see that that is equal to sine alpha cos beta plus cos alpha sine beta. Okay, which tells us we need to be able to work out sine alpha and cos alpha, but I've only got tan alpha. And I need to be able to work out cos beta and sine beta, but I've only got cos beta there. So for each of those angles, for alpha and beta, you're going to have to do separate diagrams, figure out which quadrant you're working in, go find the missing variable using x squared plus y squared is equal to r squared. And once you've done that, then you'll have x, y, and r, and you can work out your ratios over there. So let's pause and go give that a try. So for angle alpha, well, first of all, you've got to figure out which quadrant you're working in. Well, your angle lies between 90 and 270, which is here or here. And then we know that tan is positive. And all students talk crap. So tan is positive in 1 and 3. Okay, so we both occur. That's which quadrant you're working in. So in this case, we're working in quadrant 3. So you put a point in quadrant 3. Voila. And you go in an anti-clockwise direction. And that is your angle alpha over there. Now, what's the definition of tan? Shade your red with x-ray, tan your exterior. So tan is equal to y, the y coordinate over the x coordinate. But that should make you concerned because your x and your y coordinate at this point over here are both negative. So why is it not nonsense? Because if x is negative 5 and y is negative 12, then your ratio will be, for tan, will be negative 12 over negative 5, which is positive 12 over 5. Again, without the diagram, you would never have been able to pick that up. Right. So what you've got to do is you've got to go find r. So you could say r squared is equal to x squared plus y squared. So r squared is going to be equal to negative 5 squared plus negative 12 squared, which is 169. So r is equal to plus minus the square root of 169, in other words plus minus 13, but a radius is always positive, so your radius is 13. I would not have gone through all those steps. You should recognize that if x is negative 5, or if you've got a 5, 12, 13 situation, then the other dimension will be 13, okay, because of your Pythagorean triples. So you wouldn't have to show that working. But now, for angle alpha, I always do a little summary. If x is negative 5, then the y coordinate that goes with it is negative 12, and your radius is 13. Now, I can go calculate any ratio for angle alpha. Okay, right, go do the same thing for angle beta. If you haven't done that, get your x, y, and your r. Okay, so Zara has volunteered to do this for us. And she said, well, first of all, where is cos negative? Cos is negative, that's where it's positive, so it's negative in quadrants 2 and 3. Okay, because cos is a negative number. And then your angle lies between 0, which is over here, and 180. So it'll either be there or there. So which quadrant am I working in? Indeed, Zara, in quadrant 2. So draw in your angle beta. Okay. Why is the diagram important? It's to tell us whether the trig functions are positive or negative. So what are we given? Cos, which is your x coordinates over your radius. So they're telling us the x coordinate is negative 8. When that happens, the radius will be equal to 17. So you've got to go find your y coordinate. What's the diagram there for? To tell you that your y coordinate is going to be positive of some value. Okay. Right, so go find the y coordinate. Well, we know that y squared is equal to r squared minus x squared. So y squared is equal to 17 squared minus 8 squared. which gives you y squared. Y is equal to plus or minus the square root of 225. So y is equal to plus minus 15. But from your diagram, okay, just double check my answers. Yep, you can see that your y coordinate. This is why I need my diagram to tell me that the y coordinate is in fact positive 15. And guys, that's another Pythagorean triple, which for some reason I often forget, which is worth remembering. Okay, and that is 8, 15, and 17. Okay, so one dimension is 8, the other is 15, and the other is 17. Right, so now for angle beta, if x coordinate is negative 8, then the y coordinate is equal to 15, and then my radius is equal to 17. So for angle beta, I've got all three ratios. For alpha, I've got all three ratios. So now I can go on to the question. Right, so sine alpha plus beta using the compound angle formula is that. Go plug in the appropriate values and go simplify it. Give it a go. Right, so Zara is super keen and she's there. Be careful that you're working with the right angle. Angle alpha is over here. Sine is y over r for this angle. So it's negative 12, which is the y coordinate, over the radius, which is 13. But now I'm working with angle beta, which is over here. Cos is x over r, which is going to be negative 8 over 13. Okay, plus cos of alpha. So alpha, I'm back over here. Cos is x over r, which is negative 5. I'm thinking total here. Cos was equal to, negative 8 over 17. Okay, so sine of alpha is y over r, which is negative 12 over 13. Cos of beta is x over r, which is negative 8 over 17, plus cos of alpha, we're back there, was negative 5 over 13. Sine of beta, I'm back over here. Sine is the y value, which is 15. The radius, which is 17. Right, you can go and do that in your head, even though it said no calculator. Most of you will probably cheat at this point, okay, and there isn't much we could really do about it. And you end up with an answer of 21 over 221. Yep. Voila. Fantastic work, Sarah. High five yourself. Okay. So any question which involves two angles in this Pythagorean type of question, you're normally using your compound angle formula, and you've got to do two separate diagrams. Fantastic stuff. Right, exciting times. Okay, here's your bonus question on the textbook, and I want you to see how different parts of trig link up. Okay, so in the previous question we're given that information over here. Okay, that information about tan and about angle alpha and angle beta, and we were told don't use a calculator and go find sine alpha plus beta, which meant we had to go through the whole Pythagoras thing and then use a compound angle formula. How can I do this question if I said you are allowed to use a calculator? Okay, well it'll be a lot quicker. Well, what you're going to do is, we've got information, you can go find, using the fact that tan alpha is equal to 12 over 5, you can go find angle alpha. Okay, you'd have to be given some other information, either the quadrant or the diagram. Okay, so you can see why I need the diagram, okay, is to see that the angle itself must be of what magnitude. It's somewhere between, alpha lies between 180 and 270. Okay, so go use the fact that tan alpha is equal to 12 over 5, and alpha lies between 180 and 270. It's like a trig equation. Solve for alpha, given alpha is an element of 180, 270. Off you go. Don't round off at this point. Okay, so what you're going to use, your calculator, and you go shift tan to the negative 1 of 12 over 5, and it's going to give you an answer, if I can read my writing, of alpha. You get alpha is equal to 67, comma 38, I think that's it, 67, comma 38, and your general formula for tan is plus k180, where k is an integer. Okay, Well, you can see from your diagram, it's not 67,38. That would be over there. Okay, but if you add 180, you'll get to this point over here. Okay, so 67,38 plus 180 will give you alpha is equal to 247,38 degrees. You shouldn't really round off, but it's fine. Okay. Right. Likewise, now I want you to go find angle beta. How are we going to find beta? We're going to use the fact that cos beta is equal to negative 8 over 17. Okay. And we're going to use the fact that the angle lies between 0 and 180. So it's up, in other words, using all the information given, it's actually between 90 and 180. It's an obtuse angle. Okay, so go figure out angle beta. And if you use a calculator, shift cos to the negative 1, negative 8 over 17, you get beta is equal to 118,07 whatever degrees. Okay. So now I've got angle alpha and I've got angle beta. So now to work out sine alpha and plus beta, just plug in alpha and plug in beta and use your calculator. So you'd have sine alpha plus beta would be equal to sine 247,38 degrees plus 118,07 degrees. Put that into your calculator and you should get an answer of 0,095. Okay, and if you remember, when we did it without a calculator, we got an answer of 21 over 221. That was with no calculator. Okay, when we went through the whole process of using Pythagoras and finding the missing variables and using compound angle formula, so you can see that those two things you can check are the same value. So the questions normally say without a calculator, but you've got to be comfortable with linking up to trig equations and all kinds of things and understanding the different techniques that we'd use if we were allowed a calculator or if we weren't allowed a calculator. Okay? Hope that makes sense and you found your bonus question of some kind of. Okay, next one, 4.6e. Okay, it says no, a calculator with the diagram, and Calexis has volunteered to do this for us. Thank you so much, Calexis. Okay, and the angle we're working with here is 2a. Please, you can't go divide everything by 2 to say that the ratios for a will be like that. That's just nonsense. Okay, but so you're going to have to draw a diagram with angle 2a. Okay, go find your missing variable using x squared plus y squared is r squared, and then you can work out cos 2a and tan 2a pretty easily. So 1 and 2 are pretty straightforward, nothing new, just the angle we're working with is 2a, so give that a go. Okay, so Calexis, which quadrant are you in? Well, first of all, yes, sine is positive, and sine is positive in quadrant 1 and quadrant 2, because all students, okay, right? And then angle 2a lies between 90 and 270. So it can either be there or there. Where do both occur? In quadrant 2. Okay, so to draw your diagram, put a point in quadrant 2. Here is angle 2a. Okay. Right, now what's next, Calexis, is indeed you have to fill in what you're given. So shade your rear. Okay, so think of somebody shading their rear. And you're going to have sine is equal to the y coordinate, which is √5. Okay, and the radius, when the y coordinate is √5, the radius is equal to 3. Right? So when the y coordinate is √5, the radius is equal to 3. You need to go find the x coordinates. Okay, why do we need the diagram? The diagram tells us, fill that in straight away, that the x coordinate must be negative. Okay, so go work out, solve for x, and you're going to get x squared is equal to r squared minus y squared. So x squared is equal to 3 squared minus √5 squared. So you're going to get x squared is equal to 9 minus 5, which is 4. So x is plus or minus the square root of 4. so x is equal to plus or minus 2, but your diagram tells us that x must be equal to negative 2. Right. So now we know x is negative 2. So for angle 2A, if I do our little summary, we know that even the x-coordinate is negative 2, the y-coordinate that goes with it will be root 5, and the radius will be 3. Right. So there's your ratios for 2A. So now it's pretty easy. Just go work out cos 2A and tan 2A by using your definitions. Give that a go. Okay, so cos 2A is equal to the x-coordinate over the radius for angle 2A. So the x-coordinate is negative 2 and the radius is 3. So there's your answer. And then tan 2A is equal to the y-coordinate, tan, you shade your rear because x is tan your exterior. Okay, so the y-coordinate is equal to root 5 and the x-coordinate is negative 2, so it's negative root 5 over 2, doesn't matter where that negative goes. Right, the next one, you're going to have to do a bit of thinking. You only have the ratios for 2a. You can't just go divide these and say if 2a is that, then a will be negative 1 root 5 over 2, 3 over 2. Okay, you're still just working with 2a where you've halved the ratios. Okay, so you're going to have to think of a formula which links up angle A with angle 2A. Okay. Okay, so what you're trying to do is you're trying to link up 2A, a formula, you want a formula that links up, a formula which links up 2A with A in order to find sine A. So probably because you're given sine 2A, that was your first instinct. To say, okay, well I know that sine 2A is equal to 2 sine A cos A. What are you trying to find? You're trying to find sine A. Well, it's fine because we've got sine 2A, that looks good. The problem-ish is that we don't know what cos A is. Okay, so that we could go a long way around and do it that way, but it's a bit of a mission. A far easier way is to say, okay, cos 2A. Do I know cos 2A? Well, even if I didn't know it, it would be very easy to work out because you've got all your ratios for 2A, or you could calculate your ratios for 2A. So cos 2A we know, okay, and we're looking for sine A. So cos 2A we know from your formula sheet, you can go check, is equal to 1 minus 2 sine squared A. The question was go find sine A, so I'm looking for that, okay, and the only thing I need to know in order to do that is cos 2A, and we worked out cos 2A earlier on, so we're going to go use that. So go use that to go calculate sine A. Right, well we worked out, or you could just, even if you hadn't, you could do it very easily. Cos of 2A, or for angle 2A, what's your x? If x is negative 2, then your radius is 3. So cos of 2A is negative 2 over 3, which is going to be equal to 1 minus 2 sine squared A. So in other words, if I move that across, I get 2. I'm going to go over here. I'm going to have 2 sine squared A. I'll just swap them over. Is equal to 1. That was minus, cos 2A was minus 2 over 3. If I move it across, it becomes plus 2 over 3. So I get sine squared A, if you suck at fractions, just use your calculator, will be equal to 3 plus 2 is, that becomes 3 over 3 plus 2 over 3 is 5 over 3. And I've got to divide it by 2. That's that 2 over there. So sine squared A is equal to 5 over 6. So sine A, excuse the mess, is equal to plus or minus the square root of 5 over 6. But if you look at your diagram, okay, if 2A is over here, then A will be half of 2A. So A will be somewhere of angle A. So if 2A was equal to whatever, let's say that was 100, A would be 50. Okay, if 2A was equal to 120, A would be 60. All that matters is we know that it's in this quadrant over here, where sine is positive. So we know for sure that sine A is equal to positive root 5 over 6. Okay, so if you're given a double angle and you're asked to find a single angle, okay, generally it's easiest to use the cos formula. So if they'd ask you to find cos A, here we use cos 2A is 1 minus 2 sine squared A. If they'd ask us, because we're trying to find sine A, if they'd ask us to find cos A, you'd use cos 2A is equal to 2 cos squared A minus 1, and then you'd isolate cos. Okay. Okay, rat bags. Okay. Next question G says given sine 12 degrees is equal to K, determine in terms of K. So basically what they're asking you to do is rewrite everything in terms of sine 12. So first one is cos 24. Well, what's the relationship between 12 and 24? 24 is double 12, so we're going to look for double angle formulas, right? Okay, so you're looking for cos 24. So we're dealing with cos, and 24 is 2 times 12. So that, in terms of 12, is cos of 2 times 12. And we know cos 2 theta, well, it could be cos squared theta minus sine squared theta, 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. But what we were given, okay, we were given sine of 12. So in order to do the sum, I'm going to use the fact that cos 2 theta is equal to 1 minus 2 sine squared theta. So cos of an angle is 1 minus 2 sine squared, half of the angle. Right, so go try to do that now, using that formula over there. Give it a go. So cos 24 is going to be equal to 1 minus 2 sine squared of half of that. That's 2 theta, that's half of that. So 1 minus 2 sine squared of 12 degrees. Okay, which means 1 minus 2 sine of 12 degrees all squared. But what is sine of 12? Sine of 12 is k, so it's 1 minus 2 k squared. Very, very nice. Okay. Try to do the same thing with sine of 24. Okay. And let's have, I don't know, who haven't we had? Rowan. Okay. Sine of 24. Okay. Well, 24 is double 12. So we know that sine of 2 times 12 is equal to 2 sine theta cos theta. Well done, right? It must be all the coffee I've given you. Right. So go write sine 24 in terms of 12 degrees using that formula. Try it. So that's right, Rod. Sine 24 is equal to 2 sine of 12 degrees cos of 12 degrees. There's no real other option what we can start with. And sine of 12 is fine. We know that's equal to k. The problem is I don't know cos of 12. And there's a little note here that says in these kind of questions, if you've got a different trig ratio, in other words, in this case we're given sine, and now we're looking for cos, but it's the same size angle as what you're given, then you're going to need a diagram. So in other words, we've got to go find, in order to answer this question, we've got to go work out cos of 12, and that's sine of 12. So if you've got the same size angle, 12 and 12, okay, and you're looking for a different trig ratio, we need some kind of that little diagram on the Cartesian plane. So all I do is I say, right, I've got an angle of 12 degrees. I know that sine of 12 degrees is equal to k, which means k over 1. And shading your rear, so we know that for 12 degrees, if the radius is equal to 1, then we can say that the y-coordinate is k. Okay. So what are we missing? Okay, well, to find cos we need x, so you've got to go find x using this diagram over here. Go try to find x, leave your answer in third form, and then you can go answer that question. Probeer, mensen, probeer. So, now I've got, okay, I know that r squared is equal to x squared plus y squared. I'm looking for x, so x squared is equal to r squared minus y squared. So x squared is equal to 1 squared minus k squared. 1 squared is just 1, so x is equal to plus minus the square root of 1 minus k squared, which be careful, the square root of 1 minus k squared is not 1 minus k, just like the square root of 25 minus 16 is not equal to 5 minus 4, which is 1. Can't square root them separately if it's plus or minus. And from the diagram, you can see that x must be positive, so we don't have to worry about the negative. So your x is the square root of 1 minus k squared. In other words, cos of 12 degrees will be equal to, well, I know now for 12 degrees, if I've got a radius of 1, the x coordinate is the square root of 1 minus k squared, and the y coordinate is k. So cos of 12 will be x over r, which is the square root of 1 minus k squared over 1, which is just square root of 1 minus k squared. Okay, I haven't answered the question yet, because you had to go work out sine of 24. So go try to do that. And sine of 24 we know is equal to 2 sine 12 cos 12. But now I've got cos 12 and I've got sine 12 in terms of k, so it's going to be equal to 2 times sine of 12, which is k, times cos of 12, which is the square root of 1 minus k squared. Just to make it a bit prettier, it's going to be 2k times root 1 minus k squared. Okay. Right, let me just check I got that right. And I'll try this. Yep, that's it. Okay. Right, go try 3. It's pretty easy. You're going to use the working that you did previously over here in order to answer that question. Okay, try it. Take you 1 minute. Okay, and sine of 78. Well, you should know sine of 78. You don't have to show this step. Is sine of 90 minus 12, which is cos 12. Should go straight from there to there. They're complementary. Sine and cos interchange. So sine of 28 is cos 12. Here's your diagram for x, y, and r. We worked out previously. Cos 12 is equal to the square root of 1 minus k squared. Okay. Right, you still got 4 and 5 from that question. Try them. Okay. Number 4 was sine of 42. You've got to evaluate that in terms of k. So you can say sine of 42. Well, there's no double angles or anything there, but you can write it as sine of 30 plus 12. Okay. And if I go sine of 30 plus 12, Deborah, what expansion formula we're going to use? Yep, you're right. Sine of a plus b is sine a cos b plus cos a sine b. That's on your formula sheet. So go expand that. You can work out the special angles, and we know what sine 12 and cos 12 are. Okay, so you can go from there. Try that. So we're going to have sine 30 plus 12 is going to be sine 30 cos 12 plus cos 30 sine 12. Okay. Right, and sine of 30 you should know from your special angles diagram. Sine of 30 is a half. Cos of 12, well, we had these ratios for 12, and cos of 12 was the square root of 1 minus k squared over 1. So that's cos of 12. And there's the plus sign. And cos of 30 is at 30 degrees, the x coordinate is root 3, the radius is 2, and sine of 12 is equal to k, which is the same thing as k over 1. So if you times the denominators together, you get 2. So I'm going to get something all over 2. This term is going to be the square root of 1 minus k squared, and it's going to be plus root 3 k. Okay, so there's your answer for question 4. Square root of 1 minus k squared plus root 3k all over 2. Right, and then very last, but by no means least, tan of 12. Well, we had these ratios over here. Tan is the ratio of y over x, and y is equal to k, and x is equal to square root of 1 minus k And that is all of G done. Thank you to all our willing participants. Okay, the next one. You've got cos 10 is equal to P. Determine cos 5 in terms of P. Right. Let's have Miss Lapo. Right. So what's the relationship between 10 and 5? Well, the one is double the other, and I'm working with cos in both cases. So you want a formula that links up cos of a double angle with cos of a single angle. So go look at your formula sheet, Miss Lapo, and see where cos of a double angle coincides with cos of a single angle. And yes, indeed, you are correct. Cos 2 theta is equal to 2 cos squared theta minus 1. Okay, so cos of an angle is cos squared of half that angle minus 1. So right, go rewrite that in terms of 10 and 5, 10 degrees and 5 degrees. So if that's the case, it must mean cos of 10 degrees is 2 cos squared 5 degrees minus 1. Okay, hold on, Mr. Locko. And now, okay, we know though, we've got to go work out cos 5. We've got to isolate cos 5 and express it in terms of P, because we know that cos of 10 is P. And cos squared 5, remember, means cos of 5 degrees all squared. Okay, so go isolate this bit over here. Go isolate cos of 5, and then you've expressed cos 5 in terms of P. Try that. Finish it off, Mr. Lapo. Okay, so you're going to get P plus 1 over 2 is equal to cos of 5 degrees all squared. So cos of 5 degrees must be equal to plus or minus the square root of P plus 1 all over 2. Okay, but 5 degrees we know is over here. So cos is going to be positive, it's in quadrant 1. So cos of 5 is equal to the square root of P plus 1 over 2. Slapo, give yourself a pat on the back. The rest of you get that done. Hey, last question, which Valerie has volunteered to do. Please know Valerie is still wearing her paper masks, doing a riveting trade. And the question, Valerie, says, given cos 55 is equal to P, find cos of 5 degrees in terms of P. Right, so cos of 5 degrees, well, it's not a double angle or adding, okay, but we can work with a special angle and 55. So what special angle and 55 can be used to get 5? Oh, Valerie, top of your game. You're quite right. Cos of 5 is cos of 60 minus 55 degrees. Okay, so now you've got compound angles. So go look at your compound angle formula sheet, and you're going to have, what formula we're going to use? We're going to use the fact that cos of A minus B is cos A cos B, opposite sign for cos, plus sin A sin B. Right, so go apply that compound angle formula to that, and you're going to get cos 60 cos 55 plus sin 60 sin 55. Okay, and we're going to find cos 5 in terms of P. Well, we know cos 55 is P, cos 60 is a special angle, we can work that out. Sin 60 is a special angle, we can work that out. Our problem child is sin 55. Okay, I don't know what sin 55 is. Okay, but what did we say just now? We know cos 55 is equal to P. Okay, and we're looking for sin 55. When those two numbers are the same and it's a different trig ratio, that's when you need your diagram to go find the missing variable. Off you go. So go draw your diagram for 55, go find the missing variable in terms of P. So if I work with 55 degrees, here's 55 degrees, what do we know? Well, we know that cos 55 is equal to P, which is P over 1. So we know the x coordinate of P is P, and we know the radius is equal to 1. So when the radius is equal to 1, the x coordinate is P. right? So we need to go find the y coordinates, and we can see the y coordinate is going to be positive. Okay, and we're going to say y squared, yes, that's right, Valerie, is r squared minus x squared. So therefore y squared is equal to 1 squared minus p squared. So y is equal to plus minus root 1 minus p squared, but I don't really have to worry about the negative in this case because I can see the y coordinate is positive from the diagram. So in other words, okay, for 55 degrees the y coordinate is equal to 1 minus p squared. So sine of 55, which is what we're looking for, will be equal to, shade your rear, y, which is 1 minus p squared, over r, which is 1. So in other words, it's just 1 minus p squared. Okay? Right, and now I can go back to the question over here. Okay, so there's just my little aside, which I did to calculate sine of 55. So cos 5 is going to be cos 60, which is root 3 over 2. Cos 55, well, cos 55 we know is p, which is p over 1. If I've got fractions, I always put it over 1. Then I'm going to have a plus sign. I'm using this thing here, remember? Sine of 60 then is a half. Okay, and sine of 55, we've just worked that out, is going to be the square root of 1 minus p squared over 1. And how do we times fractions? Times the top and the bottom. So I get root 3 p. The bottom in both cases is 2, so I can put it all over 2. And it's going to be equal to plus, have I done that right? Sine of, I was thinking of 30 degrees. Cos of 60 is going to be a half. Oh, nearly. Valerie, you should have yelled at me. Cos of 60, at 60 degrees your x value is a half. And sine of 60 is root 3 over 2. Hopefully somebody picked that up, my deliberate error. So I get p plus root 3 times root 1 minus p squared all over 2, and if you want you can move that 3 and all, so it becomes 3 minus 3p squared. Okay, well done Valerie. Okay, well done guys, I know this is a very long lesson. Okay, so please, all homework is optional. Okay, generally these lessons are long, so we've covered everything. Okay, in class I normally wouldn't give you that homework, so you don't have to do it, but if you got through the lesson quickly and you've got some time, and it doesn't have to be today, it can be some other day where you get some time and you want to go consolidate your understanding. We haven't done these ones, you can try those as optional. Please, they're not compulsory. Exercise 4.6, page 146, B, D, F, H, and J. Okay, thank you guys. Hope you're hanging in there. May the force be with you.